real quick, before we talk about the pyramids, I just wanted to say something. A couple days ago, the James Webb Telescope officially launched into space.
That's
And it was a
her.
successful launch. Successful launch. It's a $10 billion telescope, by the way. It's a 25-year project.
Oh, this thing was
And
supposed
there's
to
this
launch like every year for the last 5 years.
yeah. No, yeah. But I watched like this super long, like 30-minute video on it talking
Okay,
about
that's
like
nice.
all of the specifications of the
Let's hear some of them.
telescope and the mirrors, and it's absolutely like mind blowing. Like I don't know if everybody knows what it looks like, but basically there's like this wind solar shield, and then there's a telescope behind that because it needs to operate at a very low temperatures, and the inside, like the processor, the image processor, something like that, needs to operate at 7 degrees Kelvin. 7 degrees Kelvin.
That is cold.
And
That
so
is
they,
very cold.
they they have this cooling system which actually works with acoustic waves, like literally sound waves. And so what it does is it sets up this standing wave where the high pressure and the low pressure areas are separated. And because, PV equals nRT, the pressure is proportional to temperature, what they do is they have like these these pipes that can conduct heat. And so they have the high pressure area um, conducting its heat into the solar shield, and so it just like radiates out into space. And then they have another pipe in the low pressure area that conducts like the lack of heat into the processor. And so it just keeps cooling it that way. So that's pretty insane. Also, there are a bunch of layers in the solar shield, and I'm pretty sure if I remember correctly, the thickest layer is 0.05 millimeters.
God damn.
The thickest
That
one.
is that is thick. That's crazy.
That's
Zero
like,
point
how
0.5
does
millimeters.
0.05?
0.05 millimeters. Oh my.
0.05, and that's the thickest one. I'm pretty sure the thinnest one is like something in the nanometers. Like, I don't even know how they like how it holds up. Who knows? Also, it's like this hexagonal, like this honeycomb shape for the mirrors, and they're all like modular. They can all like change their direction slightly. It's for adjustments. But also, one crazy thing is that the telescope is not serviceable because it's being launched to the Lagrange point L2, which is a million miles away from the
1.5
Earth.
million kilometers.
Kilometers. I said miles, but whatever. So it's gonna be chilling there, and so we don't actually have the technology to like send people to go and fix it. So it's just not serviceable. And so what they did, if something were to happen to, like, if something went wrong with the focus, the focal point of the mirror, they had to, they couldn't just send it out. They get back blurry photos, and they're like, oh well, they just leave it there. They actually made each of the modules that has like the mirror on it. They made them, like, they're able to change their concavity.
Yeah, that makes sense. I was actually just gonna ask if because yeah, because
Yeah.
that 100%. No, that had
So
to be
they can
something like that.
change their direction, like where they point, and they can change their concavity. So they can just adjust the whole focal point action. And yeah, go ahead.
For a reference, because I don't know if many people even understand how large 1.5 million kilometers is. Hubble,
Yeah.
for example, is like 500, 600 kilometers from the surface
Well,
of
it's
the Earth.
orbiting the Earth.
Orbiting the Earth. Yeah, it's like very, 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 very close, and that's our most sophisticated telescope out there. And this guy is now 1.5 million, basically around and looking at an unrestricted view of the sky, which is much far, far greater than anything we could have ever achieved or even hoped to have achieved with the Hubble, right? Also because of
Yeah.
atmospheric, a lot of things in there that it's obviously also being prevented.
But the reason why it's going all the way out there is because these Lagrange points are basically points in the, I guess, the solar system, but it's pretty relative to the Earth and the Sun and the Moon. I guess you do need to take that into consideration.